Welcome toppers. So now we are going to start the topic RMS value of alternating current or voltage. Let's begin the topic. RMS value of a current. Let us now calculate the average value of I square over one complete cycle. What is the mean of RMS? That means root mean square value. So here what I'm just trying to do, as you can see over there, this is the value of average. Okay, that means mean value. If I just do square, so that will root mean square value. Understood? So what I'm going to do here, the find the root mean square value of a current. This is a root mean square value of a current. Okay. So like this is the average value of a current which we calculated in the square form for a complete cycle. So we know that sine square omega t is equals to 1 minus cos 2 omega t by 2. I'll just put this value over there like I naught square by t 0 to t 1 minus cos 2 omega t by 2 dt. So I square RMS value comes in the nature I naught square by 2t. If I just differentiate this term, if I just integrate this term, sorry for the differentiation term used, I just use in it. So if I just integrate this term, that will becomes t minus sine 2 omega t by 2 omega. Because the integration of a cos omega t is sine omega t by omega. Now, there will be a little bit calculation over there. As you can see, we reached this point. I'll just take in for a calculation this terms only. So, as you can see, t minus, instead of omega, I'll just put 2 pi by t over there. As you can see. Okay. Now, I just put the limit. So instead of a small t, firstly I'll just put capital T and then 0. So if I just multiply it by t, that means 0 to any other term, that comes 0. So final, as you can see, like this will be t and t. Sine, the value of a sine n pi will be 0. So this value again comes 0 and overall value which we will come, that is a t. I hope you understand this complete terms. So the integration of this complete factor comes t value. So I square RMS square is equals to I naught square by 2 comes in the nature. Okay, because as you can see over there, this value comes I naught square by 2t into t. So t will be cancel out each other and we get this value. And where I naught, if I'm just talking about what is the I naught, so earlier I was told you I naught is a peak value of a current. Peak value of current. And if I just take a root over there, so this is the square mean value, and if I just take a root, so root mean square value comes I naught by root 2. We know that value of a 1 by root 2 is equals to 0.707 I naught, so 0.07 only. So that value of I naught by root 2 is 0.707 I naught. Okay. Similarly, the case of RMS, the EMF will be E RMS is equals to E naught by root 2, which is 0.707 E naught. Note that point to be remember about RMS value of AC. Given AC source voltage is RMS voltage. Current in AC circuit is RMS current. AC ammeter and voltmeter reads the RMS value of a current or a voltage, that is the effective value of alternating current or a voltage respectively. AC can be measured by using hot wire ammeter or hot wire voltmeter because the heat generated is independent of the direction of a current. Heat is a scalar quantity, so it is independent of the direction of a current. AC produces the same heating effect as that DC of a magnitude I is equals to RMS. Some important points regarding to the AC, like AC is more dangerous than DC at the same voltage. For example, like we have 200 AC means ERMS will be 200 volt and E naught will be 200 root 2 times of V. And if I'm just taking 200 volt DC means 200 volt. So AC can be produced the principle of electromagnetic induction. Because of that, the E naught factor came and that root 2 factor came in some nature. So AC obeys the Ohm's law and Joule heating laws. If I naught is peak current, then RMS current, that is IRMS, will be. So like now I am just going to take few questions for more memorization power increased, like from your side students. So these are the options. The correct answer for this question is answer 2 and 3. Like 2 will be I naught by root 2, and as I earlier briefed you, like 1 by root 2 is 0.707. Okay, so the RMS value of a current is equals to I naught by root 2. Hope you this term will be clear to you. Now moving ahead, the average EMF during the positive half cycle of an AC supply of the peak value E naught is E naught by pi, E naught by root 2, E naught by 2 pi, and 2 E naught by pi. The correct answer is 2 E naught by pi. So this is for today's class only, students. I hope you understand the peak value, what is the mean of peak value, what is the mean of like RMS value for current, or how we can calculate the RMS value of a voltage also. So thank you for watching this video. So keep watching the Nagin Best Learning School of Education. This is a particular team which provides you the data, the information about the examinations, most important topics, and their process. Thank you.